Next, we're moving on to talk about descriptive statistics and a little bit about visual displays of data. So let's say we collect some data for a research study and we're interested in college students and their socializing behavior. So we could ask students, how many nights did you go out in the last week? And here we get kind of this big mess of numbers. You can see this person here went out 7 times. They're very cool. This person went out 0 times. They're probably a graduate student. It's really difficult though to discern any patterns just based on these numbers kind of in a hodgepodge here. So the first thing we'd want to do is organize them. And here we have a frequency table. And all we've done here is determine the range of scores. So in this case, as we saw in the previous slide, it ranges from 0 nights per week to 7. And then all we did was tabulate the number of people who had each score. So you could do it with tally or tick marks, but here on this table, it's the actual number or the frequency. This frequency table's already done a nice job of organizing the data and making it easier to look at, but sometimes we like to have a visual picture of what our data look like. So in this case, we could use a histogram. So a histogram is like a bar graph that's used to display interval data. So the values of the variable go on the x-axis. You can see here the number of nights out socializing, and then the frequencies go on the y-axis. So again, you can see really clearly that one person went out 0 times, one person went out 7, and the most frequent response was 4 nights per week. You can see here we had 5 people that responded in that way. One thing that I want to point out is if you have a wide range of numbers, for example, if you were doing something with salary, age, height, weight, anything where you have really long chains of numbers, a histogram and frequency table can get a little unwieldy, so you might want to make what's called a group frequency table, in which case you might have ranges here instead of the actual numbers. So now that we've organized our data and we've displayed it in a visual way, we can move on to some of the basics of descriptive statistics. So a lot of this is probably review, but we're talking first about central tendency measures, and that includes the mean, median, and mode. So the mean simply means the average, and that's our first official formula for this class. So all we did to calculate the mean is to add up all of the numbers and divide by the total number of values, or in this case, participants. So if we add up all the people who responded to our survey about going out on school nights, we find that on average, college students went out about 3.4 nights per week. The mean is kind of like the balance point for our distribution of data. As you can see here in the picture, it perfectly is going to balance the two sides. So besides the mean, what else can we use to measure central tendency? We can also talk about the median, which is the middle score in a distribution. The thing to point about the median is that the scores need to be arranged in order. So again, we could find that pretty easily with our data here. And then the last one is the mode, which is just the most frequently occurring score in a distribution. So that's a pretty simple one with our mean, median, and mode. So to help you remember, we have a little mnemonic device here. Hey diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that appears the most, and the range is the distance between. So kind of a cute rhyme. You can amuse your friends and family with that, but it'll help you keep the different measures of central tendencies straight. One last thing to consider when we're talking about measures of central tendency is this idea of outliers, which your book talks about. So outliers are extreme scores that are either very high or very low in comparison with the rest of the scores in a distribution. So these can be very influential and can even distort our data. And your book talks a little bit about skew, both positive and negative skew. So the mean is highly susceptible to being affected by outliers. So if you think of something like the average income of people living in Omaha, Nebraska, that number might be skewed if you include our good friend Warren Buffett. So because his salary is so much higher compared to the rest of Omaha, it's going to drag the mean up and make it look like people in Omaha are making more money than they actually are. So that's a good example of when we might use the median instead. So we might talk about the median income, median housing prices you see frequently, because the median value won't change, whereas the mean is susceptible to those outlier scores. So measures of central tendency are very basic descriptive statistics. They're incredibly useful, but in addition, we sometimes want to know a little bit more information about our data. So let's switch over to the whiteboard and we'll look at a couple of examples. Here we have some sample data. We'll pretend that these are exam scores, and we have them from 3 different classes. If we take a look at class number 1, we can go ahead and add up all those scores and divide by the total number of people in the class to get the mean or the average. So if we do that, we add them all up, there's 7 people in the class, we end up with a class average of 80% in that case. So we'll move over here to class number 2 and we'll do the same thing. We'll add up all the scores and divide by the total number of people. And in this case, we also get 80%. And we'll go here to class number 3. And I know you're working on this in your heads, but spoilers, this one is also 80%. So the moral of this story is that all 3 classes have an average on these exam scores of 80%. So I could sit back and say, well, I must be an excellent teacher. Everything is fine. My students are doing great. But when you look at the actual distribution within these classes, you can see that they're telling very different stories. Here for the class number 1, we have scores that range from a 60% up to 100. Class 2, we have scores ranging from 20 to 100, but you can see the vast majority got hundreds. Only those 2 people failed. And then we have class number 3, where the scores only range from about 78% up to a high of 82. So although the means are all the same across these classes, we'd be interested to know more about how the scores are dispersed or how they vary. This brings us to chapter 3 in your textbook, when we're going to talk about measures of variability. So here we have 3 different ways to measure variability in a sample. First, we have the range, which we just looked at in that previous example. So we have the high to the low score. We can also talk about the variance, which is the average squared deviation from the mean. And finally, we can talk about standard deviation, which is variation from the sample mean. So the range is pretty straightforward, as we just saw in the previous slide in our course example with the 3 different classrooms. So I want to talk a little bit more about variance and standard deviation. So at this point, we can think about variance as really a step on the way to get standard deviation, because the 2 are related. Basically, when we're calculating variance, we're going to subtract the mean or the average from each individual score. We're going to square that number, that deviation number. We're going to add it all up, and then finally we're going to divide that number by the total number of people in our sample. To take that a step further, we would have that final variance score, and we would take the square root of it to calculate the standard deviation. You generally don't see variance talked about a whole lot in journal articles or in statistics, but people know what standard deviation is and have a pretty basic working understanding of it. So we're talking about the average or the typical amount that scores vary or deviate from the sample mean. You can also think about this as the square root of the variance. And both of these formulas can be found on page 22 in your book. The notation's a little bit different here. I thought it would make a little bit more sense to label it SD for standard deviation. So let's walk through a really simple example on how you can calculate this. And again, you would never really have to calculate this in real life. SPSS will do it for you. You can actually do it in Microsoft Excel, but I just want to show you an example to illustrate at a conceptual level what standard deviation is and how it relates to variance. So let's take a look at how we can calculate variance and standard deviation. We'll do a little walkthrough, again, just at a conceptual level. I'm going to use Microsoft Excel because it's a little bit easier to organize data. So here in column A, you can see we have variable X. It can be whatever you imagine it to be. It could be a happiness score, number of beers someone drank, anything you can imagine. So we'll just label it X, and you can see that we have 5 people that are in our sample. And they have a score of 1, 5, 7, 8, and 9. So our first step is that we want to take the mean or the average. So we'll simply add those up and divide by 5, and we end up with an average of 6 in this case. So our next step is we want to subtract that mean of 6 from every single score. So I'm just going to label this column X minus the mean. So if we take 1 minus 6, that gives us a negative 5. 5 minus 6 gives us a negative 1. 7 minus 6 is a positive 1. 8 minus 6 is 2. And 9 minus 6 is 3. So you'll notice that if we were to sum all of these up, that it would actually all cancel out to 0. And this is one of those fun mathematical things that mathematicians have figured out a way around. So instead of just trying to add those numbers up, we're going to go ahead and square each one. So I'm just going to add on to our formula here. We're going to do x minus the mean, and then we're going to square it. So negative 5 squared gives us 25. Negative 1 squared is 1. Positive 1 squared is 1. 2 squared is 4, and 3 squared is 9. So now if you're following along with your formula, we can add up this column here. So if we add up this column, it adds up to 40. If you want to double check yourself, Excel's nice because you can highlight it and you can see down here it gives us the sum total, which is kind of a cool feature. So now that we've summed all of these squared deviations, the next step in our formula is to take this sum and divide by the total number of people in our sample. So in this case, it'll be 40 divided by 5, and that will give us a total of 8. Oops. So this 8 actually corresponds to the variance. And in order to get the standard deviation from that, all we need to do is unsquare that column, or in this case, take the square root of the variance. So if we take the square root of 8, you might need a calculator for this one, but we end up with a standard deviation of 2.82. Our standard deviation, again, is telling us on average how the scores deviate from the mean. So we would say on average, the scores deviate from this mean of 6 by about 2.8 points on whatever the scale may be. So you can actually do this using Microsoft Excel really easily using the formulas. If you hit the equal sign in a cell and start to type in, if you're like me, you have these formulas memorized, but otherwise you can pick from the formula functions here. So you can see the one that pops up, it says STD-EVP. So that's going to be standard deviation for a population, which is what we just calculated by hand. So if I select that, all I have to do now is highlight the data and hit return or enter. And you can see it calculated that a whole lot quicker than we just went through those steps. So it's kind of a nice little shortcut if you ever need to do this in your jobs or you don't have access to SPSS and you don't feel like doing hand calculations. So again, in that case, it's a standard deviation of a population. That formula is on page 22 in your book, and it also gives you the formula for the same thing but based on a sample. And we'll talk later in this course on why those are two different formulas. So going back to our slides, you can see here this is kind of a visual representation of what standard deviation is. So you see here we have our mean of 6. This person who answered a 1, they deviate from that a total of 5 points. This person who answered a 7 deviates only 1 point, but we would say on average for this collection of scores, they deviate from the mean about 2.8 points. So it's a way of indexing or classifying what the deviation of the scores is like. And here's just kind of a quick guide to calculating the standard deviation again. First step was, of course, finding the distance between each score and the mean. We had to square that. Remember that if we calculate the average of the deviations, we're always going to get 0, which is why we have to square those. We found the average of those, which we would call the variance, and then finally we took the square root of the variance to get the standard deviation. The last thing that I want to mention is the idea of how we might visualize data or display data. Your book talks a little bit about different types of charts, but I think this is a really important issue, so I wanted to spend a little bit of time going through some examples and talking about some best practices when it comes to visualizing data. So here we have an example of a graph, one that you might see. In this case, this one's from Fox News. It's from 2010. If you want to check out this article here, I've provided the hyperlink, and it really does a nice in-depth analysis about things that are wrong with this graph. So on first glance, you see we have job loss by quarter. It's in all capital letters. This line is red and it appears to be sharply increasing. There's kind of some red shading below here. It just makes us look like, things are really terrible right now. However, if you take a step back and take some time to really look at what the graph is saying, there's actually quite a few things wrong with it, and it's really incredibly misleading. So it says up here, job loss by quarter. So down here we have December of '07 to September of '08, which is actually a total of 9 months or 3 quarters. So that's not really a quarter where I come from, probably where you come from too. And then here we have March of 2009 to June 2010. That's actually 15 months or 5 quarters. So the graph is incredibly misleading because the intervals on the x-axis here, first of all, they aren't quarters, which is what the chart is saying they are, but they're not equal. So that's what's giving it that really sharp increase that you're seeing there. The second thing, you see down here, the source is the Bureau of Labor Statistics. And if you click the hyperlink and read a little bit more into the article, it explains that these numbers here aren't even job losses. These are actually total number of unemployed people. Because you could imagine if 15 million jobs suddenly disappeared, we would notice that. So this actually isn't job loss, but it's unemployment. So the unemployment data, it comes from the Bureau of Labor Statistics. You can check it on the census data. They update it every month. So there's really no excuse to kind of have this misrepresentation of data presented in this inaccurate kind of manner here. Here we have another one. This was more recent. This was when the Affordable Care Act rolled out, and there's quite a bit of controversy about enrollment and whether or not people would meet those goals. So you can see here the goal of 6 million people as of March 27th. Here we have March 31st. The goal is a little over 7 million. And it just looks like things are hopeless. We're never going to meet that goal. It's just a complete mess. And again, there's a hyperlink down here that will analyze it a little bit more in depth. But let's take a look at how we might re-envision this graph. Here we have the original graph with the numbers, but the main point is look at the axis here. The previous axis, number one, it's not really labeled, so we don't know what unit of measurement they're using, but it's certainly not equal intervals because it creates just this dramatic shift in the bars, which in reality, if you just use a nice round number to label it, it's actually not that far off. So that's another example of how you can mislead with graphs if you don't use equal intervals on your axes. So I would hate to just pick on Fox News because other people are guilty of making poor graphs as well. So this one comes from NBC Nightly News with Brian Williams. This is a few years old as well. This is kind of an interesting one. It's talking about the changing face of America, and we're looking at percent of total U.S. population by race and ethnicity from 1960 projected to 2060. So I think this one's kind of funny because they have this graph overlaid over the United States, and the color coding is really strange because it looks like, for example, all of the Asian people who would be purple, they all live up here in Maine. All of the people who are other, whatever that might mean, they also live in Maine. I guess there's a few Asian people that live up here in that corner. Alaska is solely white people, along with a good chunk of the states. So this is a nice example of how you can use shapes and imagery and colors to mislead, because this graph isn't actually breaking down race and ethnicity by state. It's just been arbitrarily laid over a map of the U.S. So you can see down here in the bottom, the original source is from the Pew Research Center, and they do really great work. And here we have their original graph. So it's not pretty to look at. The colors could use a little bit of work, but it's a much clearer picture about how the racial and ethnic makeup of the U.S. is changing over time and how it's projected to change in the future. So by looking at these changes in area, we're able to get a clearer picture versus trying to lay it over a map of the U.S. and making it look like other people only live in Maine. So that's a pretty amusing one. And again, the link does a nice kind of analysis of how to make good infographics versus not so good infographics. So just a couple of general goals and guidelines. You really want to only include the variables of interest. You don't want to distract the reader with extraneous information or try to scare them with things that aren't relevant, unless I guess you're a news source and that's kind of what you're interested in doing. You want to make sure that the graph is self-explanatory. So always including a title, labeling your axis, and most importantly, labeling the units of measurement. We want to avoid this idea of chart junk, which is again kind of extraneous things. There's a lot of different features you can use when making graphs, like in Word or Excel. You can make these 3D pop-up graphs that are just insane looking and really difficult to interpret, and again can be used to mislead readers. But at the same time, we want to be creative, but also keeping the goal of effective communication at the forefront of our minds. So hopefully you enjoyed that little overview of data visualization. You could teach an entire class on it, and I'll provide some resources if it's something you're interested in learning more about. But I definitely encourage you to check out some of those hyperlinks and how they break down the analysis of those different terrible graphs.